next up, we have David Mascarenas, who's going to tell us about the lessons he learned from a cheap, lightweight barbecue grill. Can't wait to hear about it. David.
Hi everybody, my name's David Mascarenas. The idea for this presentation started about 4 years ago. My roommate and I at the time had just bought a barbecue grill, and I was assembling it, and I actually have a background in structural engineering, and I noticed that many of the tricks you see in structural engineering actually go into barbecue grills. So you can see this is a little bit of my background. I have formal training as a machinist. I have various education in engineering as well. This is some of the stuff that I've built over the years to give you some idea. It's kind of all over the place. Everything from surfboards to machines to jewelry to race cars, coincidentally enough, for where we're at. So metal sculptures as well. So I actually noticed in engineering school and in machining school, they often teach us to either build things or analyze things, but rarely to design things. And you really need to design something before you can analyze it or build it. And there were many tricks we learned to actually design things that were structurally sound. So while I was in San Diego, my roommate Billy and I, we'd be jamming, building surfboards, cracking on things, having parties with our friends. We needed to have barbecues to fuel all this. So we had to buy the barbecue grill. And like I said, as we went and started assembling the barbecue grill, I noticed that many of the little tricks that I'd learned up, kind of picked up off the street of engineering, so to speak, actually go into the barbecue grill. And if you observe barbecue grills or many other consumer products, you can start to see these things. So I want to point out right from the beginning, people oftentimes talk about strength in structures. And this is an example of a strength failure. A failure of strength is when a material actually permanently deforms or breaks apart. That's usually not actually what we're concerned about. We're usually concerned about stiffness failures. So if you look at this board that my roommate's standing on here, you can see it's clearly bowed down. Now, if this was your deck, you wouldn't want your deck bowing like this. It's not broken, but it's not high performance either. So to give you some idea of how stiff the material in a barbecue grill is, it's about 50 thousandths of an inch thick. This is 40 thousandths of an inch thick steel. You can see it's clearly sagging under its own weight quite significantly. So to give you some idea, when you bend something, think about this. The material on top elongates. The material on bottom shrinks. So if you think about it, the more material you have elongating and stretching, the more difficult it's going to be to do that, and the stiffer it's going to be. The stiffness is what we really care about oftentimes. And if you go to engineering school, they'll teach you about this. It turns out what you really want to do is have structures that are very tall in the direction of this load like this. And you want to have a lot of material out here that has to stretch or elongate. And that's why channels are the way they are, and I-beams. And you can see these kind of I-beam structures all throughout barbecue grills, even in the handle, in this plastic handle. It's essentially kind of like a channel. And that really stiffens things up, but it's very light and very cheap to build. If you look at the shelf on the barbecue grill, you have a big pot of beans, but this doesn't sag. And it's because it has these stringers. And these stringers basically have to have a lot of material that needs to elongate and stretch. So this doesn't really sag. If you look at the whole body of the barbecue grill, there's a couple of things going on here, but conceptually you can see the bottom and the top here both are essentially channels. There's a few other things going on, but this big channel shape has a lot of stiffness to it. Your grill doesn't deflect. Now, an interesting thing, if you didn't have this lip on your barbecue grill and you were to push on the side of it, it would deflect in quite easily. And this lip is actually kind of like a channel. And this adds significant stiffness to your grill. And if you want to demonstrate this at home, get an aluminum can, cut it in half. And if you squeeze on this guy in the middle like this, you'll see it deflects quite easily. But if you add just a little material by just kind of cutting out the bottom of the can like this, and you try to squeeze that in, it won't deflect at all. And so it's a similar principle. And this is one of my favorites. If you look at these big holes in the barbecue grill that are on the bottom, in a structure, this would cause you to lose a lot of stiffness. But if you look, they add this lip right here. And that's really nice because that really helps the structure maintain its stiffness for minimum weight, and you still need to have the hole oftentimes. So I used to build race cars, and we'd have to apply this principle whenever we were building these monocoque structures out of composites. Typically, you'd need these holes going on, and these holes would need stiffness to keep the whole car from bending. So it turns out this structural engineering concept's applied to food as well. So hot dogs always break this direction. This is a hoop stress failure. You can learn more about it if you read a solid mechanics book. It's kind of interesting. So if you're interested in learning more about tricks of structural engineering, you can learn a lot just by observing how consumer products are made. You'll see many of these things in like the snow shovel, for instance, with these ribs, or your cup, or a cheap sled, or this is my mop. And if you look at things like motorcycles and stuff, you'll see it too. So that's it.
Thank you, David.